So today I want to talk to you about simplifying expressions. If you recall from our conversation yesterday, this is an example of an algebraic expression. And what makes it algebraic is that it has variables. A is a variable and B is a variable. And it has operations, addition, and subtraction. It also has multiplication. 7a means 7 times a. 4a means 4 times a, and 3b means 3 times b. So it has numbers, variables, and operations, which is what makes it an algebraic expression. So let's review some of the other vocabulary that's important. The word term refers to a number or the product of a number and a variable. So in this case, 7a is a term, 4a is a term, 3b is a term, and -6 is a term. So this is kind of important, that the negative sign in front of the 6 goes with that 6. So remember how when we talked about this before, I had you circle terms? You would always circle the sign that goes in front of either the variable or the number. And so this is a 4-term expression. That number in front of the variable that tells you how many times that variable gets repeated is called the coefficient. It is simply the number that is being multiplied times the variable. This expression has 3 coefficients, 7, 4, and 3. The -6 is called a constant because it is a term that is just a number. It always stays the same, and there's no variable attached to it. So the constant in this case is -6. So you might want to copy this chart down. You can pause the video while you do that. First thing you should do is circle the terms. So in this first expression, we have 2 terms. They are 6y and +2. The coefficient would be 6, and the constant would be 2. Now, like terms is what you have when you have the same variable as different terms. And the reason for calling them like terms, it's like the same unit of measure. So if you have feet and feet, you can combine them, right? Here, we don't have any like terms because there are no other y's as part of this. So we would write none. All right, in the second expression, 3m is a term, -2n is a term, +n is a term, and -4. So this is a 4-term expression. The coefficients would be 3 and -2 and 1. Now where's the 1? Well, the 1 comes from the 1n. So you don't see a 1 there, but anytime you have a single variable, it means one of them. So let's go to the constants. Would be -4 because that is a number that doesn't change. There's no variable attached to it. So now like terms. Like terms are those that can be combined. What could be combined here? Well, we have n's and other n's. Those are like terms because they are the same variable. So we would write -2n and n as our like terms. Now, if we wanted to combine those like terms, we could because they are the same thing. If we had -2 of something and then +1 of something, that would give us, when we combine them, a -n. Okay, on the next one, we have one term. It has a coefficient of -4. There are no like terms and no constants. In the next one, we have 9m, 2r, -2m, and +r. So the coefficients, what numbers are being multiplied times the variable? Well, there's a 9, there's a 2, there's a -2, and there's that understood 1 that goes with the r. There are no constants here because every one of the terms is a variable in it. So now what could be combined? What are like terms? Well, we're looking for the same variable. We have m's here and m's here. So we would call 9m and -2m. Look how I wrote that. I didn't put a comma because really what we're going to do when we combine them is we're going to put 9m and -2m together to give us some 7m. And then we have r's, and we have positive 2r, oops, positive 2r and a positive r. So we could write those as 2r plus r. And again, we would actually do that addition when we combine the like terms to give us 3 r's altogether. Okay, on this last one, 4x minus x plus 8x minus 10. Very simple. If you go through the expression and circle them, it becomes very obvious what you have. So our coefficients, we have a 4 in front of the x. We have a -1 because this negative x means -1x. We have an 8, and that's it. We have this -10 goes in the constant column. And now we could put 4x minus x plus 8x as our like terms. And when we combine them, that would give us 11x's. So we can represent algebraic expressions using symbols. So when you see this green rectangle, that is going to represent our unknown. In this case, we're calling it x. And when you see the yellow squares, that's going to represent a positive constant. If the squares were red, they would be negative. So in this case, we have 2 x's here, and we have 3 more x's over here, and then we have 4 constants, 4 squares that represent a +1. So we can simplify this expression by combining the like terms. All of the rectangles could be put together and all of the squares could be put together. So we could rewrite this as 5x's plus 4, and that would be called its simplest form. So when you're simplifying, a good habit is to circle the terms like we just practiced. So in this case, we have 3a, +2, 4a, and -1. So of those, the like terms would be the variables, 3a and 4a, which would give you a total of 7a's. And then we could combine the constants of 2 and -1 to get a +1. So this expression is a simplified version of the original expression. So here we have -4m and -9m. They're both the same variable, so we can combine them to -13m. We have 5y's and another y, gives us 6y's. P, 6p, and -4p can be combined to give you 3p's. And then 3b and a -b can be combined to give you 2b's. So those examples we just did only involved addition and subtraction, and based on order of operations, we could do those just going left to right. But what if there's multiplication in the expression? This one says 4g plus 3 times the quantity of 3 plus g. So because there's multiplication, before you can combine like terms, you have to take care of that multiplication. So we'll use the distributive property. 3 times 3 is 9, and 3 times g is 3g. So this multiplication can be rewritten as an addition problem. And so now we can look at combining the like terms. And in this case, the 4g and the 3g are like terms that can be combined to give you 7g's plus the constant of 9. Now in this one, this is just addition and subtraction, so we're just going to combine the like terms. 6y and -7y give you a -y. 4m's plus another m is 5m's. This last example, though, if you just take a moment and read it, it involves multiplication. So you take care of that multiplication first. Now, if you read this out loud, it's 4x plus 3 minus 2 times the quantity of 5 plus x. This -2 is the number that we're going to multiply times everything in the group. So it's -2 times 5 is -10, and -2 times x, which is -2x. So now if we rewrite the remaining part of that expression, you can see that we do have like terms of 4x and negative 2x, which would give us 2x's, and then a positive 3 and a negative 10, which is a negative 7. All right, so your assignment is on page 118. I have attached the answer keys so you can check yourself after you work on the problems. If you have any questions, feel free to reach out to me. Talk to you later.